Problem 1. If f of x equals 2 to the x, then f of x plus 2 minus f of x minus 2 is equal to what? You'll notice that this really isn't a calculus problem, but it is going to be a simplifying problem that we might find useful as we're taking derivatives and doing some of the derivative problems. So this one is just asking me to plug in x plus 2 and then plug in x minus 2 and then subtract them. So to get f of x plus 2, I'm going to go into here. Wherever there's an x, I'll put x plus 2. So it's going to be 2 to the x plus 2 minus, then on this one, we will get 2 to the, this time I'll just put in x minus 2. Okay, now from here, this is where the trickiness begins. I do notice they both have a 2 to some power, so generally what we do when we have 2 to some power is just take out the smallest power. So if I had to pick between x plus 2 and x minus 2 is the smaller power, so we're going to factor that out front. Okay, now usually when we do that, I'm just going to do a little sample problem up here. Let's say I have x to the 6 minus x to the 4. I would factor out an x to the 4, and then I get x squared minus 1 left. And that's kind of the same process that we're going to use on this one. Notice to get this 2, really, I subtracted those 2, so I did 6 minus 4, and that gave me 2. So that's exactly what I'm going to do on this one. I'm going to take 2x plus 2 minus x minus 2. And then minus, if I divide 2x minus 2 out of 2x minus 2, I'll just get 1. Right, from here we're just going to try to simplify it. This will be 2 to the x plus 2. I'm going to distribute that minus sign, so I'll get minus x plus 2 minus 1. Notice that the x's are going to cancel. 2 plus 2 will give me 4, so this will be 2 to the x minus 2, and then 2 to the 4 minus 1. So I have 2 to the x minus 2, 2 to the 4 is 16 minus 1. That will equal 15, so my answer will be 15 times 2 to the x minus 2, which is option B. Okay, question 2. Find the limit as x approaches infinity of 3x to the 5th minus 4 over x minus 2x to the 5th. Okay, I know as I'm approaching infinity, I'm going to be comparing the degrees. So we're going to compare the degree in the numerator versus the denominator. And if the degree in the numerator is greater than the degree in the denominator, my answer will be infinity. If my degree in the numerator is less than the degree in the denominator, my answer will be 0. And if the degree in the numerator is equal to the degree in the denominator, whatever, then my answer will be the ratio of the leading coefficients. So if I'm looking this up, I'm comparing the degrees. The highest one up here is 3x to the 5th. Down here I have negative 2x to the 5th. So notice the degrees equal each other. So the leading coefficients are 3 on the top and negative 2 on the bottom. So that is my limit, and that was option A. Okay, question 3. Let y equal uv be the product of the functions u and v. We would like to find y prime of 1, and then it gives me some information. Okay, a couple keywords. First of all, they tell me that y is a product, so when I'm taking the derivative, hopefully that pops into my head that I would like to use the product rule. So first of all, I'm going to find y prime, and then we'll be able to plug 1 in. Okay, so this is very similar to this is f and this is g. So f prime is equal to the derivative of u will be u prime, and for g, the derivative of v is v prime. So if I use the product rule, I'm going to get y prime equals f prime times g, so we'll get u prime times v plus f times g prime, so u times v prime. Okay, and then the thing is we want to find y prime of 1, so to get y prime of 1, we'll find u prime of 1 times v of 1 plus u of 1 times v prime of 1. And notice that they gave me all that information. So u prime of 1 is equal to 3, and then times v of 1 is equal to negative 1, plus u of 1 is equal to 2, and then u prime of 1 is equal to 3. Oh, that's a v, I believe. So let's change that. v prime of 1 is equal to 1. So if I simplify this, I'm going to get negative 3 plus 2 which equals -1. So my choice will be B this time. Okay, problem 4. The graph of y equals f double prime is shown, consisting of two straight line segments. Great. If f prime of 0 equals 0, then in the vicinity of which of the following values of x the curve y equals f of x falling and concave down? Okay, a few things that we need to recall from this. If it's falling, that means f is decreasing. And then we're talking about concave down. Okay, if the function is decreasing, I know that f prime will be negative. So that's one thing that I want to keep in mind. And then if the graph is concave down, I know that f double prime will be negative. All right, so if I'm looking at this, first of all, I need f double prime to be negative, and this is the picture of f double prime. So I notice in this section right here, f double prime is negative. So anywhere between 3 and 9, f double prime will be negative. So if I want it to be concave down, I can cross off A and I can cross off E because those x values are not between 3 and 9. Okay, so I've now narrowed it down to 4, 6, and 8. So I need to find out which one of these values will f prime be negative. All right, so the way that I'm going to do this is f double prime, and I need to know something about f prime. So to get from f double prime to f prime, we are going to take the integral. So to take the integral of f double prime, and I'm just going to start the integral at 0. So we want to find f prime at 4. So the first one I'm going to go to 0 to 4. The next one I want to go 0 to 6. And then the last one I want to go 0 to 8 because I'm testing 4, 6, and 8. I want to find out what's happening with f prime. Okay, to get an integral, when we're given a picture, it's just the area under the curve from 0 to 4. So if I look at the area under the curve from 0 to 4, it's going to be this little spot right here. I notice that that is going to give me a positive answer. Remember, I need f prime to be negative, so that is not going to be a possible choice. Okay, now going from 0 to 6, it's going to be this area and this area. I notice that those two areas are going to cancel each other out, so I'm going to get an answer of 0, and that is not negative, so I can cross it off. And then going from 0 to 8, if I go all the way over to 8, I notice that there's more area underneath the curve than above, so my answer will be negative, which means that f prime is negative at that spot. So 8 is going to be my answer. Okay, question 5. If the integral from 0 to 4 is 10, from 0 to 5 is 9, from 4 to 7 is 1, then what is the integral from 5 to 7? Okay, I'm going to set myself up a nice little chart here, and hopefully that will help me out. Okay, if I'm going from 0 to 4, the area under the curve there is 10. Okay, and then I know 0 to 5, this whole thing is going to equal 9. And then I know from 4 to 7, so coming up here, from 4 to 7 is 1, and I want to know what it is from 5 to 7. Okay, so just a few things that I can notice here. First of all, I know this whole thing is equal to 9. This part is equal to 10, so this part right here would have to equal -1, because then 10 minus 1 would give me 9. And then from here I notice, okay, this is -1. I need to figure out what would this be so that the entire integral is going to be 1. So if I had made that be 2, then notice 2 minus 1 would give me 1. So my answer is going to be 2.